Students, this is the sixth part in the series. We're taking a look at the Unit 3 Inequalities review. This is the fifth lesson that we're doing, and we're reviewing for Inequalities quiz. We've already done the do not together. That's the first part. The second part was interpreting solutions to inequalities. The third part was looking at solving inequalities. And the fourth part was graphing compound inequalities. We just did the fifth part as well, which is interpreting graphs. Now we're on to the sixth part, which is solving compound inequalities. For each of the compound inequalities, we're supposed to graph it on the number line after we solve it. So let's try to solve them. You already should have done these, but if you haven't, please pause the video, try these out, and then come back to see if you get them right. All right, for that first one, we added 9 to both sides to try to isolate that variable x, and then we divided by 3 on both sides. We're using inverse operations to try to get x by itself. So x is less than or equal to 10/3, which is x is less than or equal to 3.3 repeating. There's no line for that on the number line, so I just put it in between 3 and 4. It's a filled in circle because of the equal sign here, and x is less than, so we're going to be shading to the left. X is greater than or equal to 10, starting at 10, filling in the circle because of that equal sign on the bottom, and shading to the right. Now, hold on a minute. There is an and on this. And means the two highlighted portions, the two shaded regions, have to be overlapping. Since these are not overlapping, do you remember what happens? Right, no solution. If it says and, the two lines have to go into each other. They have to intersect each other. They have to overlap each other. If there's no overlap, we say no solution. Moving on to number 2, both of these inequalities have to be solved. Pause the video, try this out, and then come back to see if you get it right. In the solution process here, we divided by a -3. Of course, when you divide by a negative number in an inequality, you flip the inequality sign, so that becomes x is greater than or equal to -4. That's that graph here in black. This second inequality is solved like this. We add 3 to both sides, and we get x is greater than or equal to 8. So now I'm going to highlight or start at 8 and put a arrow to the right. So it looks like this. Graph looks like this, starting at 8, filled in circle, and going upwards. Notice that they are overlapping here. This is a rare instance in which an OR inequality has 2 arrows that are going in the same direction. If that happens, OR means both of these solution sets, I should say, are correct. So I can just leave it this way. I don't have to erase anything. I don't have to put no solution. OR means both of them are okay. All right, 2 weird graphs to start off with. Let's take a look at some of these other graphs. Pause the video, try this one out, and then see if you get it right. Things first, we split the compound inequality into 2 simple inequalities so that we can solve each individual inequality. Now, on both sides, or on both inequalities, I should say, I'm going to add 3 to both sides, add 3 to both sides. That will isolate the variable. That tells us that x is greater than 9, because 9 is less than x. It also tells us that x is less than -1, which means both of these can be graphed on the number line. Another rarity here, as this compound inequality certainly looks like an AND inequality. However, when you solve the individual inequalities, you can see that x is greater than 9, so that's shaded upwards. X is less than 1, or less than -1, so that's shaded downwards. The one thing that I have to change on this graph, however, is both of these are open circles. So let's change that now. Open circle because there's no equal sign. All right, done with this problem. Moving on to the next problem. Again, separate and solve. First simple inequality starts at -10 and ends at 8, so that's here. We subtract 8 from both sides and then divide both sides by 2 and get x is greater than or equal to -9. In other words, -9 is less than or equal to x. I also get, starting at the 2x and ending at the 2, 2x plus 8 is less than 2. I, again, subtract 8 from both sides and divide both sides by 2. It's going to be the same procedure for solving on both sides because this 2x plus 8 isn't changed. At the end of the day, I get x is less than -3, so it's got to be less than -3, but greater than or equal to 9. Here's what it looks like. And here's the situation I have. The -9 gets a filled in circle. I know that x is greater than -9, so I'm shading it upwards. And then x is less than -3. -3 gets an open circle, and I'm shading downwards. Done with that problem. All right, moving on to 5, 6, 7, and 8. I'm going to go a little bit faster through these ones. Try these out, and then come back to see if you got them right. In that first inequality, we have 12 is less than 3 times x plus 2. That's here. We solved by distributing, then subtracting 6 from both sides, then dividing both sides by 3. Same thing here. I started at 3 parentheses x plus 2 is less than negative 6, and I simply distributed, then subtracted 6 from both sides, then divided by 3. Now I have my compound inequality ready. Let's graph it up. So since 2 is less than x, we say x is greater than 2. That's this part here. Open circle because no equal sign. X is less than negative 4. That's here. Open circle because no equal sign. All right, perfect. Moving on to question 6. Split them up and then see if you got it right. So since we have greater than or equal to 0 here, x is greater than or equal to 0, we're going to shade upwards from 0. And then x is also greater than negative 0.5. So I am going to put another overlapping arrow over it. It's a little messy, but that's just how it works. All right, moving on to question 7. We're solving each of these individually and then graphing them on the number line. Here we go. And here we did the distributive property to get 6 plus 2x is greater than 4. Then we're moving that 6 to the other side and dividing both sides by positive 2. Since I divided by a positive number, the inequality stays the same. X is greater than negative 1. In this case, though, I move the negative 3 to the other side, make it a positive 3, and then I have to divide by negative 2. Since I divide by negative 2, I'm flipping the inequality sign. X is greater than or equal to negative 3. So here's what the graph looks like. And here are your correct and complete graphs. We had an open circle here, but that got covered up by the shaded in region here from x is greater than or equal to negative 3. And last but not least, number 8, solve and then graph. Last graph is a little bit more our speed here. It says that x is greater than negative 13, starting from negative 13 and going upwards. X is less than 10, starting from 10 and going downwards. All right, this was the video on solving compound inequalities. It was part of the larger video series on the review of inequalities for Unit 3. All right, folks, good luck studying.